Hello GATE aspirants, welcome to part 10 of GATE Mathematical Physics series. Question number 4. For the differential equation d2y by dx square minus n plus 1 y by x square is equal to 0, where n is a constant, the product of its two independent solutions is. Now for this equation we can multiply throughout by x square. So x square into d2y by dx square minus n into n minus 1 into y is equal to 0. Let us put x is equal to e raised to t here. That means ln of x is equal to t. Now we know dx square d2y by dt square. This is Cauchy's equation, Cauchy-Euler equation, and this is equal to d2y by dt square. This is x here. d2y by dt square minus dy by dt. So the equation will be d2y by dt square minus dy by dt minus n into n plus 1 into y is equal to 0. So this is d square minus d minus n into n plus 1 into y is equal to 0. So let us find out its rule. So d is equal to minus b, so that is plus 1 plus or minus square root of b square minus 4ac. So 4 into ac. So 4n into n plus 1. So minus 4ac minus minus it will become plus upon 2 into a. So this is equal to 1 plus or minus under root 1 plus 4n square plus 4n. So this is square of 1 plus 2n. So this is equal to d plus or minus 1 plus 2n upon 2. So d1 will be equal to 1 plus 2n upon 2, which is equal to 2 plus 2n upon 2, that is 1 plus n, and d2 is equal to 1 minus 1 plus 2n upon 2. So d2 is equal to n. So we have two roots minus n. So we have two roots n plus 1 and n minus 1. So y is equal to c1 e raised to n plus 1 into t plus c2 into e raised to minus n into t. But e raised to t is x. So c1 into x raised to n plus 1 plus c2 x raised to minus n. So the roots are n plus x raised to n plus 1 and x raised to minus n, and their multiplication will be x raised to n plus 1 into x raised to minus n is equal to x. So their product is x. So option B is correct. During a rotation, vectors along the axis of rotation remain unchanged. For the rotation matrix, the unit vector along the axis of rotation is. So the matrix is 0, 1, 0, 0, 0, minus 1, minus 1, 0, 0. And it is operated on x1, x2, x3. And then we are getting same vector. So x1, x2, x3. So this is equal to x2 minus x3 minus x1. This is equal to x1, x2 and x3. So from here we will get x1 is equal to x2 and x2 is equal to minus of x3. So that means x1 is equal to minus of x3. So if we consider this to be 1, then x3 will be minus 1. So x will be 1, 1 and minus 1. And we can normalize it. So it will be 1 upon under root 3. So here option B is correct. The pole of the function f of z is equal to cot z at z is equal to 0 is. We have f of z is equal to cot z, which is equal to cos z upon sin z. So singular point will be when sin z is equal to 0. That means z is equal to 0. Now it will be of form 1 by 0. So it is 1 by 0 form. That means it is a pole. and it is pole of order 1. So here option C is correct. Next question. The value of the integral minus infinity to plus infinity cos x upon x square plus a square dx, where k is greater than 0, a is greater than 0 is. Now the integral is from minus infinity to plus infinity. So let us consider a contour like this, and this integral we will replace x by z, and this cos function we can write it in terms of exponential form. So this function f of z, it will be real part of e raised to I kx, so that will be cos kx, upon we have z square plus a square. Now let us find its singular points. Singular points will be z square is equal to minus of a square, that is I square a square. So z is equal to plus or minus ia. Now here it is given that a is greater than 0. That means this will be plus ia or minus ia, and plus ia will be in this side. So z is equal to ia lies inside the curve. So that means we have to find residue at z is equal to a by a. Z is equal to ia. This is equal to numerator as it is ikx. Here it should be ikz. Ikz upon derivative of denominator, which is 2z, at z is equal to ia. So this is equal to e raised to ik ia upon 2 into ia. So this is I square, that is minus 1. So e raised to minus ka upon 2 ia. Now value of integral is equal to 2 pi I into sum of residue. Here it is minus ka upon 2 ia. So 2i will cancel out. This is equal to pi by a e raised to minus ka. So option A is correct. Next question. Let theta be a variable in the range minus pi to pi. A function is given. If its Fourier series is written like this, then the value of C3 mod of C3 square is. So this function is given. The formula for Cn is equal to 1 upon 2 pi minus pi to pi, this range, complete range, f of x e raised to minus I nx dx. So C3 will be, it will be 1 upon 2 pi integral minus pi to pi f of x e raised to minus I 3x dx. Now the function is equal to 1 in this range. So 1 upon 2 pi minus pi to pi by 2 1 e raised to minus I 3x dx. Because only in that range the function has value equal to 1. Otherwise it is 0. So 1 upon 2 pi e raised to minus I 3x upon minus I into 3, and limits are from minus pi by 2 to pi by 2. So C3 is equal to 1 upon 2 pi into minus of I3 into e raised to, first it is pi by 2, so that is, here we have minus sign, so we can change this sign. So limits will be exchanged. So this will be I 3 pi by 2 minus e raised to minus I 3 pi by 2. So this is 1 upon 6 pi I into a raised to I 3 pi. So this is cos of 3 pi by 2 plus I sin 3 pi by 2 minus cos of 3 pi by 2, minus it will be plus I sin 3 pi by 2. This is 0, 0, and this is sin 3 pi by 2 is minus 1. So this is minus 1 and minus 1. So this will be minus of 2i. So we have 1 upon 6 pi I into we have minus of 2i. So this I and I will cancel out and we will get answer minus 1 upon 3 pi. So this is C3 and we have to find value of mod of C3 square. So mod of C3 square is equal to 1 upon 9 pi square and this is equal to 0.011. So answer is 0.011 and answer given in the answer key, this range is 0.010 to 0.013. So these were all the questions from GATE 2019 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.